Meta AI just dropped a breakthrough so powerful, it may have reset the boundaries of artificial intelligence reasoning. It's called DeepComp, short for Deep Think with Confidence. And just recently, it scored an almost impossible 99.9% accuracy on the AIME 2025 math exam, one of the toughest problem-solving tests in existence. What makes this achievement even more stunning? It wasn't done with a closed corporate black box model. It was done with an open-source giant, GPT-OSS 120B. That alone would be headline-worthy. But the way Meta made it happen, that's the real story. The old way, parallel thinking. Until now, most large language models got better at problem-solving through a brute force strategy called parallel thinking. You'd ask the model to generate multiple solution paths for the same question. Then you tally up the most common result, a majority vote. It works, but it comes with two major flaws. One, diminishing returns. After hundreds of tries, accuracy barely improves. In fact, too many bad solution paths can start polluting the final vote. Two, massive cost. Every extra trace means more tokens, more compute, more time, more money. So yes, you get more accuracy, but at a painful cost. The DeepComp shift. DeepComp flips the script. Instead of treating every reasoning path as equal, it listens to the model's own confidence signals. Think of it this way. When you're solving a math problem and suddenly feel unsure about a step, that's your brain warning you. This path might collapse. DeepComp gives AI the same intuition. It can spot low-confidence stretches and either filter them out after the fact or stop them early before wasting compute. How confidence is measured. Here's where it gets clever. Token confidence. Every word or symbol the model outputs carries a probability score. High score equals high certainty. Group confidence. Smoothing out the noise by checking larger chunks of tokens, sliding window style. Tail confidence. Zooming in on the final steps, where answers usually appear and where mistakes often happen. Lowest group confidence. Highlighting the weakest stretch in the reasoning. Bottom percentile confidence, shining a light on the absolute worst sections. Together, these signals create a health report for every solution path. And that's the magic. Instead of wasting thousands of tokens on bad reasoning, DeepComp knows when to stop. Offline and online modes. Meta designed it to work in two ways. Offline mode, generate multiple solution traces, then filter out the weak ones, let the strongest reasoning win. Online mode, if confidence drops below a threshold, the model literally halts mid-answer. No more wasting time finishing doomed responses. The result? Across tests, 43% to 85% token savings with accuracy that actually went up. The benchmarks. The numbers speak for themselves. On AIME 2025, GPT-OSS 120B scored 91.8% pass at 1 on first tries. With majority voting, it climbed to 97%. With DeepComp, an astonishing 99.9% while saving 84.7% tokens. Other models saw similar leaps. DeepSeek 8B, 83%, 93.3% with 78% fewer tokens. Qwen 332B, 80.6%, 90.8% with 56% fewer tokens. When you're already near the ceiling of what's possible, those gains are massive. Plug-and-play simplicity. Here's maybe the most surprising part. No retraining, no specialized data, no hyperparameter magic. It's literally plug and play. Tweak the log probs processor to track sliding confidence. Add an early stop check before emitting tokens. Pass confidence thresholds through the API. That's it, around 50 lines of code. Production ready with barely a hiccup. The model behind the breakthrough. Now, about that record-setting model itself, GPT-OSS 120B. A 120 billion parameter transformer, but not a general-purpose one. It was trained through curriculum learning, starting with simple problems, progressively moving to advanced ones. It even learned from wrong answers, strengthening its reasoning. Specialized math datasets, textbook-level problems, and fine-tuned attention mechanisms turned it into a math powerhouse. Why the AIME matters. The AIME exam isn't your average test. It gives students 3 hours, 15 problems, no multiple choice, no shortcuts. Every answer has to be a single integer from 0 to 999. Problems are designed to trip up even the best, and only the elite make it through, the future Olympiad-level solvers. So when DeepComp nails 90.9% accuracy, it's not memorizing. It's reasoning, rivaling the very best human problem solvers. Open source, power with transparency. Of course, Any technology this powerful sparks concerns: misuse, misinformation, bias, irresponsible applications. Meta's answer? Keep it open. Open sourcing DeepComp and GPT-OSS 20B means everyone can inspect the code, stress test the weaknesses, and contribute fixes. Instead of being locked in corporate vaults, this becomes a global collaboration. And people are already experimenting with local setups, VLLM, Llama.cpp, pushing it even further. Flexible by design, DeepComp even comes with adjustable modes. DeepComp Low, keep only the top 10% of most confident traces, maximum efficiency, minimal cost. DeepComp High, keep 90% of traces, more stable accuracy, still big gains. You choose cost savings or peak performance. The bigger picture. DeepComp proves something profound. AI doesn't just need brute force. It can use self-awareness of confidence to reason smarter. And because it's paired with an open source model, this power is now available to everyone, not just big tech. Closing in comments. Got thoughts? Drop them in the comments. I'll be reading and featuring some of you in the next one. Don't forget to hit like, subscribe, and turn on notifications so you don't miss what's next. Thanks for watching, and I'll see you in the future.